Okay, we're going to do the trigonometry questions of the September 11th workshop. Let's just get started. Here we go. We start with this. It says 13 sine A minus 5 equals 0, and cosine A is less than 0. Calculate without using a calculator the value of sine 2A. Well, the first thing you've got to do is change this 13 sine minus 5. Just rearrange it a little bit. In other words, add 5 and divide by 13. Now you know that the sine of the angle is 5 over 13. Now, we wouldn't know, I'm going to leave this out of here, I wouldn't know that. That's what I do first. Now it says the cosine of A is less than 0. Well, two things are happening here. The sine of A is positive. Now, positive 5 over 13. But the cosine of A is 0. Well, you can use all stations to Cape Town to figure out that the only place where sine is positive and cosine is negative is the second quadrant. So the only place that can happen, cosine's negative in the second and third quadrant, sine is positive in the first and second quadrant. The only place where both of those things happen is the third quadrant. And that's why you draw your picture right here, right here. Now, you make a triangle here. You drop this straight down. You go to this quadrant and make a triangle. Now, you know that the long side is 13, and you know that the short side is 15 because it's opposite over hypotenuse, opposite over hypotenuse. Now, how did I know that this was 12? You use Pythagoras to go 13 squared minus 5 squared, and you get a number like 144. You take the square root, and it's equal to 144. The square root is equal to 12. But you know, because you went to the left, it must be minus 12. Well, once you've got this whole picture, you're ready to figure out everything else, including, let's take a look at the sine of 2a. So we knew this was, opposite over hypotenuse. So 5 is opposite. There's your hypotenuse. Your adjacent side is minus 12. Well, the first thing, sine of 2a, you go to your formula sheet and you write down 2 times the sine of a times the cosine of a. And now you can just fill in the rest. The sine of a, well, you go to, this is the triangle you're working with. The sine is 5 over 13. Hey, we were already given that. But the cosine of a is negative 12 over 13. So we just put that number in. This isn't a very nice one. I just put this in my calculator. Well, 2 times 60 is 120. 13 squared is 169. The answer is minus 120 over 169. And that's it. There's the first one. Let's take a look at the next one here. Ooh, there's quite a bit of work in the next one. So it says, without using a calculator, determine, without using a calculator, all this stuff up here, the tan of 60 degrees, the sine squared of negative 135, the cosine of 390, the cosine of 180. There's a lot of things we're going to need. You have to know if you go to 135 degrees, the reference angle is 45 degrees there. So I'm going to need my special triangle for 45 degrees. The tangent of 60 degrees, I'm going to need my special angle for 60 degrees. And since they said the sine of 270 and the cos of 180, all that stuff there means you're going to need to figure out a way to show without a calculator what the cosine of 180 is. And just do a little basic graph of cosine, starting at 1, going all the way through to 360. Just stop at 180 and show that you know it's down at minus 1. The other one, the sine of 270, just make a basic sine graph from 0 to 360 degrees. Go to 270 and show that it's minus 1. So my two pictures show that I know the cosine of 180 is negative 1, and the sine of 270 is negative 1 as well. Okay, let's try some of the other stuff here. The cosine, let's just go through all the things I was able to figure out. The first one, the tan of 60. I go to 60 degrees. It's root 3 over 1. I rub it out and put it in like that. That should be worth a mark. I go the sine of negative 135 degrees. I go to where it is. The reference angle is 40 degrees, but it's negative down there in that. If I bend to where that is, that's the third quadrant, and sine is negative there. But what you're doing is taking that thing and squaring it. We're going to square it, so it's better to put a bracket around it and square it. Before, the sine of 270 is negative 1, and my little diagram here shows that the sine of 270 is negative 1. The sine of 150, the reference angle is 30 degrees, but it's positive there. The cosine of 180 degrees, I showed that it's negative 1. Negative 1 would be all right just to write in there. But the cosine of 390, it's all the way around. The reference angle is 30 degrees. Okay, let's keep working this thing. The cosine of 45 is 1 over root 2, so you write in 1 over root 2. It's negative, but when we square it, it's going to become a positive. The cosine of 30 degrees, go to 30 degrees, is root 3 over 2. So there's my root 3 over 2 instead of the cosine of 30. The sine of 30 is opposite over hypotenuse. It's 1 over 2. There's everything all figured out. Hey, but some things are going to simplify here. Negative squared is positive. 1 over root 2 is really just 1/2. So this whole top is just root 3 over 2. Well, in the bottom, there's a root 3 over 2. Well, that just cancels, but you're left with one negative here. So that turns into negative 1. This whole thing becomes root 3 over 2, but it cancels with the thing on the bottom and just becomes minus 1. Now, over here, the sine of 30, you've got a half on the bottom. 1 divided by a half is just 2. But 2 minuses make a plus. That's minus 1 plus 2. The whole right side becomes just 1. 2 minus 1 is 1. Well, then we divide by that 2 in front. We've got the cosine of theta is equal to a half. Well, the cosine, I know the angle that fits with a half. The cosine of 60 degrees is equal to a half, and I can see it here. The cosine of 60 degrees. Well, I know that the cosine of minus 60 gives me the same answer as 60 degrees. And also, the cosine of 300 degrees is exactly the same as the cosine of 60 degrees in that first and fourth quadrant. So there's all the answers between minus 180 and 360 degrees. There's 3 solutions that will equal a half. Minus 60, 60, and 300. You could try it on a calculator and see that it's true. But I can tell that it's true because I worked out 60 degrees. I know minus 60 gives me the same answer in the fourth quadrant, and all the way around to 300 degrees gives me exactly the same answer because the reference is 60 there. Well, there's that one down. We'll do one more video for the last question. Okay.